All right, this is Geometry A, Unit 4, Lesson 11, Making Predictions with Transformations. There's not a lot of actual new material in this lesson, but it's asking you to kind of summarize and use what you've learned so far to make predictions. In this particular case, I'm going to give you two cases. I'm going to do this. I'm going to translate according to two rules. I'm going to translate according to the rule xy becomes x minus 2, y plus 5. And then I'm going to translate according to the rule xy becomes x plus 3, comma, y minus 1. Okay, and I'm just going to do it visually. You remember that x minus 2 is left 2, and y plus 5 is up 5. So left 2 and up 5, 2, 4, 5, A prime. Left 2 and up 5, 2, 4, that's 2, 4, 5, B prime. Left 2 and up 5, 2, 4, 5, C prime. Okay, we've translated according to the rule and ended up with this triangle. There we go. Okay, and then we translate according to the second rule. And I'm going to show you how to compose those transformations into something shorter here. Let's go yellow. Okay, plus 3 is right 3. Minus 1 is down 1. So right 3 and down 1. 1, 2, 3, down 1. That's A double prime. Right 3, down 1. 1, 2, 3, down 1. B double prime. Right 3, down 1. C double prime. Okay. And I want to notice the end result. Obviously, these are rigid transformations, so the shape is still congruent to its original shape. All the angles and side lengths are preserved. But if you compare the orange pre-image to the final image, the yellow, you can see that there is this amounts to being a single transformation. And I'm just going to sketch this one. Right 1 and up 1, 2, 3, 4. Right 1 and up 4. So this amounts to this transformation. Xy becomes x plus 1, y plus 4. Now notice what's going on here. Minus 2 plus 3. This is a combination of both of them. It's x minus 2 plus 3. Minus 2 plus 3 is plus 1. Y plus 5 minus 1, y plus 5 minus 1 is y plus 4. Okay? And so we can combine these. Let me give you another example without drawing. Let's say we translate according to this rule. X, y becomes x plus 17, y minus 2. And then we do xy, and we do x minus 4, y minus 3. We can combine that by addition, integer addition. Plus 17 minus 4, x plus 17 minus 4 is x plus 13. y minus 2 minus 3 is y minus 5. And so this amounts to a single transformation of xy becomes x plus 13y minus 5. Hopefully that makes sense. You can combine translations by addition, by adding integers. All right? The other one I want to explore is this. What if I take the original shape and whoops, I'm doing the wrong thing. I thought I was erasing layers. Okay. There we go. Okay, I'm going to hide the graph, and I'm going to hide the grid. And I just want to generalize something here. If I do a double reflection across intersecting lines, okay, let's say I reflect across this line, and then reflect across this line, and they're intersecting lines. This is going to be a reiteration of what we talked about before, and I'm going to just sketch it here, okay, rather than reproduce it in an exact form. But the reflection across the line is perpendicularly the same distance, so C prime, okay, perpendicularly to the line, same distance, A prime, thereabouts, and B something like this, B prime. Okay. And we get, it's a rigid transformation, so we get another triangle that's congruent to the original. Note that I haven't drawn it very accurately. Okay, but now when I reflect it again across this line here, perpendicularly, same distance, B double prime, perpendicularly, same distance, A double prime, and perpendicularly, the same distance, C double prime. What we get is a rotation. The orange triangle has been spun, right? Spun by a particular angle, right there. And if I label this angle, and I think the textbook used the Greek letter alpha, you can label it anything you want, then this angle of rotation, which is this angle between the two triangles, is twice that. So if alpha, if the angle of rotation was 50 degrees, then the angle between the lines is 50 degrees, then the angle of rotation is 2 times 50, or 100 degrees. Okay? So that's another idea presented in there. Double reflection across intersecting lines is equal to a rotation twice the angle between the lines of the angle between the lines of reflection. All right, hopefully that helps.